Welcome to the tutorials of Strength of Materials by Civil Thinking. Now, in this series of video lectures, we will slowly develop an understanding of the bending stresses and how to calculate the bending stresses of all types of beams. And this is our first class. Here we are going to just introduce what are bending stresses, right? So let's begin right now. So let me begin with a simple example. As you can see on your screen, it's written, our body is stressed by carrying a load on our back. The load will try to bend you, but you don't want to bend, but definitely you will be stressed out. So what it is saying, it's saying if you are carrying a load on the back, that means example it's you, and you are carrying a load on your back, right? You are carrying this load, a box on your back, and this box will exert a load on you, right? It will try to exert a force on you, and this force is in downward direction, and it will try to bend you in the downward direction. But of course, when you carry a load, you have to reach somewhere and you don't want to bend and give up, right? So what is going to happen? You will resist the bending, right? It will try to bend you. You will resist the bending, and because of resisting the bending, you will be stressed out, right? Stressed. All right. Now if we consider, now look at this beam, this now look at this box. It is exerting force on it, and the force will exert the shear forces on it, on your body, and it will also exert bending moment on your body, like here this will exert bending moment, here it will exert bending moment. Okay, so the concept is this load will induce shear forces in you, it will also induce bending moments in you. Okay, and you will be stressed trying to resist the load. Okay, you are trying to resist the load. This is why you will be stressed. All right, this was just a simple example so that you will get some, real life touch of what is bending stress is. Let's move on. Now what's exactly the concept in the structures? So as you can see, the load on a beam tries to deform the beam by inducing shear forces and bending moments, but the beam will resist deforming itself, which will cause stress in the beam, right? Now let me draw a simple beam. Like you have a beam here, this is a support, and on the support this is another support. For example, this is a roller support, and this one is a pin support. Okay, and a beam is on it, right? Like this, a beam is on it. Now when I apply a load, external load on it, like this is a load, right? Now this load will try to bend it, right? Something like this. But this beam will not bend easily. Okay, this beam wants to fight this load back, it will resist. Okay, now this load, as you can see, first let me say, this load will exert some shear force here, right? Shear force also at some distance. In fact, at all the sections, the load induces shear forces and bending moments, right? At every point, here will be a bending moment, right? Like this moment, because load is here, so this load will try to rotate this point in this direction, so there will be a bending moment, right? So the beam will resist the bending. Okay, it will resist, it won't try to bend, right? Now because of this, the stresses will be induced, right? Stresses will be induced, And why are these stresses? These stresses are due to shear force and the moment which are developed in the beam. Okay, these are the stresses we are talking about, and we in this series of video lectures we are going to find numerically the stresses. Okay, now let's move on. Now here we have introduction to the theory of simple bending. It's written, the stresses developed in a beam can be calculated numerically, but it will be very hard because it will involve complex equations to solve. Now let me tell you what this sentence means. Here I have told you these are the stresses, right? The stresses are induced in this beam, right? And why are the stresses induced in this beam? Because this load, let me change the color, this load has caused two things, right? This I can write here, this load has caused two things. It has induced bending moment in the beam, right, at all the sections. It has also induced shear forces in the beam. Okay, now these two together, right, they will try to bend the beam, right? But what is going to happen? Beam will resist, right? Beam will resist. Now there is resistance, it will try to resist. Of course, when you resist something you get tired. Actually, you when you resist something you get stressed, right? Because you work against those forces which you are trying to resist. You work against them and the stresses will be generated, right? There will be stresses, right? Now this is what we want to know. We want to know the magnitude, how much. We want to know the direction of these stresses, right? This is the motive of this series of video lectures. Now here is a problem. When you consider the shear forces and bending moment both, okay, of course there will be stresses, but the thing is that if you consider both bending moment and the shear forces, if you consider both of them acting, these stresses will be found. Of course they will be found, but they will be very tedious. It will be very hard to find the stresses. I'm not saying it's impossible, it is possible definitely, but the thing is that it we cannot have a simple equation. Okay, we just cannot have a simple equation to find these stresses. Okay, and we want a simple equation. We don't want to use a lot of computer programs to find these stresses. Okay, therefore it has been found, if we neglect this shear force, okay, we will only consider the bending moment, then these stresses now are very easy to find. Okay, now they become simple to find. We can derive an implicit mathematical formula to find these stresses when we ignore the shear forces. Okay, now there is a theory which is famously known as theory of pure bending or theory of simple bending, which has done the same thing. What it has done is it has ignored the shear forces, or it has considered those sections where the shear force is zero, and only in those sections there is some bending moment. Because there is zero shear forces, now this theory of simple bending has derived a simple formula to find out these stresses. And yes, besides ignoring the shear forces, besides saying that the shear force, let the shear force be V, shear force is zero, it has other assumptions also. Okay, I think I have said more than this one line. Maybe I have said all the things here. Okay, and generate a simple equation. Okay, I have told you everything what is written here. So that comes the concept of theory of simple bending. It is a theory. There are assumptions that the shear force is zero, and also there are few other certain assumptions which we will see in the next class when we see the theory of simple bending. And yes, theory of simple bending, some books have also called it, written is it as theory of pure bending. It doesn't matter, what is important is the concept behind it. And in the next class we will see the concept behind theory of simple bending, and also we will derive that simple equation. Okay, now that's it for today. And of course, if you want the PDF of this video lecture, you can download it from the description or in the comments. And also, if you have any problems in the strength of materials, mechanics of materials, please contact me. I will definitely help you in your strength of materials problems. And also I provide tutorials in the strength of materials. You can learn one-on-one live online with me. I also offer teaching classes. For that you can also contact me. And that's it for today's class. See you in the next class. Thank you.